In example 7, we are solving linear inequalities, such as the one you see here. What makes this a linear inequality instead of an equation is that this sign right here is not an equal sign. In this case, it's greater than or equals. One important difference between inequalities and equations is a linear equation, as we've already seen, will only have one solution, whereas inequalities could have infinitely many solutions. As far as solving a linear inequality, the process is pretty much identical to that of solving a linear equation, with one important difference, and that is whenever you multiply or divide both sides of an inequality by a negative number, you need to flip the inequality sign or turn it around. Okay, so let's see how this works. Just like with an equation, my first step is to get rid of all of the parentheses by distributing. So that's going to give me 2x minus 6 on the left-hand side, greater than or equal 5. Now I have a minus 3 that I am distributing through, so I need to make sure that that negative gets taken to both terms. So I'm going to have minus 3x and then minus 3. Okay, now let's simplify a little bit on the right-hand side. I'm going to get 2x minus 6 greater than or equal to 5 minus 3. I'm going to combine those two terms. 5 minus 3 is 2 minus 3x. Okay, so again, just like with an equation, my goal is to put all of the x terms on one side of the inequality. So I can do that by adding 3x to both sides. So in this case, I'll be moving all of my x's over to the left-hand side. And I'm also going to add 6 to both sides to put all of my constant terms on the right-hand side. Then when I perform those operations, I'm going to get 5x on the left, and on the right I'm going to have 8. Then I divide both sides by 5, and that's going to get me x greater than or equal to 8 over 5, or another way of saying that is x greater than or equal to 1.6. So that's the answer, but we are asked in this case to give our answer in interval notation. So to explain how that works, let me first draw a quick geometric sketch of our solution. So let's say I was going to draw a number. Let's say we have a number line here. And let me mark off 1.6. Okay? So our solution is all x larger than or equal to 1.6, greater than or equal to 1.6. So 1.6 is a solution to this inequality, but any number larger than that is also a solution to this inequality. So geometrically, this red arrow indicates our solutions. Now we have a special notation for representing sets like this, and it's called interval notation. So the basic idea is the set of solutions would be all of the numbers from 1.6 all the way up to infinity. So I put 1.8 comma infinity, and then 1.6 comma infinity. 1.6 is included in the solution, so I put a square brace here. I would use a parenthesis if it wasn't included, and in fact around the infinity I put a parenthesis. The reason for that is somewhat technical, but the idea is that infinity is not a real number. You never actually get to infinity, so we don't actually include it. So this is the answer to this inequality in interval notation. Okay, let's take a look at another example. So this is part B. So the first thing we notice in part B is that we are dealing with fractions. So there are, again, multiple ways that you can handle expressions like this involving fractions, but what I prefer to do when it's possible, I like to multiply both sides by some number to get rid of all of the fractions. In this case, after looking at it for a while, it seems to me that 6 will do the trick. So I'm going to multiply both sides of this inequality by 6. The left-hand side as well as the right-hand side. And that's going to give me 6t over 2 minus 6 times 2/3 is 12 over 3, less than or equal 6 times t over 3 is 6t over 3, plus 6 times 2 is 12. Okay, so simplifying this, I'm going to get 3t minus 4 less than or equal to 2t plus 12. I'm going to subtract 2t from both sides. And add 4 to both sides. Okay, so that's going to leave me with just t less than or equal to 8. Okay, so my answer is all values of t that are less than or equal to 8. Geometrically, that's going to look like this. There's my number line. This is 8. My solution is 8 and everything smaller than that. So we could say that that's everything from minus infinity up to and including 8. And so in interval notation, that would look like this. Everything from negative infinity up to and including 8. And so this would be our solution.